So if you check, there is this question that we're going to do now. So this question, it states that it was in question 2014. So it's question number 3. So in this question number 3, it says that given if not or is a fundamental matrix of X, which is AX, at T0 equals to 0, and if F is continuous in T, then we have this X of P of T equals to that, then is a particular solution of the non-homogeneous system, where this is the non-homogeneous system. Use the results given above with T equals to 0, T0 equals to pi over 2 to find the solution of the initial value problem. So we have this initial value problem, which we are given is a system. Then we are also given that if you substitute in this system, this is a derivative of the first system that was original system. Then when you substitute in the original system, you get this 4 and 7. So now what are we have to find the solution of this initial value problem. So we are given x of p of t, and then also we are given that this non-homogeneous equation, it can be written in this form. So when we find the first thing that we're gonna do in order for us to find the solution of this system, given all this information, we will have to first find the eigenvalues. To find the eigenvalues, we're gonna take this matrix. We're gonna use this matrix, the first, this 3 minus 2, 5, and minus 3. Then when we use it, so when we use it, we're gonna get the absolute value of, it's gonna be 3 minus lambda minus 2, and it's also gonna be 5 minus 3 minus lambda, which is going to be equal to, then it's gonna be 3 minus lambda and minus 3 minus lambda. Then 5 times 2 is going to be 10, which is going to be minus 10 is going to be plus 10. So we all know that this is going to be equal, so you can multiply back. Can you hear my voice properly?
Yes, I can hear you.
All right, no problem. Then when you multiply, it's going to be negative 3 times negative 3 is going to be 9, negative 9. Then this is going to be negative 3 lambda. This 1 times that is going to be plus 3 lambda. This is also a lambda there. Then plus lambda squared plus 10. We all know everything here must be equals to 0. So if we simplify this, we'll see that this is going to be, we're going to have lambda squared. Negative 9 plus 10 is going to give us 1. This will cancel with this one. Then we're going to be left with plus 1, which is equals to 0. So when we're left with that, then our lambda squared here, if we take 1 the other side, it's going to be negative 1. It's like we're going to have lambda squared equals to -1. So when we take the square root of both sides, then we're going to have lambda equals to plus or minus I. So the square root I means that I equals to square root of -1. So we're going to have plus or minus I. So when we have plus or minus I, then we can start with a case 1, when your lambda equals to I. So case 1, when the lambda equals to I, we're going to substitute in the same matrix that we're working with when a lambda equals to I. Then when we substitute, we're going to get, we will get gonna be 3 minus I and minus 2. Then we have 5 again. Then we're gonna have minus 3 minus I again. This one here, we just want to find the value. It's the same way the way we're doing before when we substitute lambda. Then we know that we can find V1 and V2. Then we also know that this is going to be equals to 0. So when we find this one, the same way we did before, we're going to take, you can write it in terms of gaseous elimination. Then when we do it, you will see that if we say 3 minus I of 5 and minus 2 minus 3 minus I given 0, then we can try to solve this matrix. So when we solve it, you will see that in this one here, if we say 3, in this one here, this is our V1 side of and V2. So if we try to solve it, you will see that our V1 equals to that and V2 equals to this one. So if we have 3 minus I here, and we also have minus 3 minus I. So we can try to find a way that we can make this like this way to be 0, this 5. So in order for me to make this 5 to be 0, I can multiply this equation on top there. This is R1 and R2. So I can multiply R1 by 5. Then I can also multiply R2 by 3 minus I. I'm going to multiply R2. So the results here, I'm going to subtract them. I'm going to say the equation is going to be this minus, let's say minus to get R2. So I'm going to write the equation is going to be 3 minus I minus 2. Then when we know that if we do this one minus this, the way it is, that we are going to get 0 here. So there is no need for us to calculate, because the reason of doing that is for us to accumulate 0. But now if we say 5 times minus 2, we know that we are going to get minus 5 times minus 2 is going to give us minus 10, as minus 10 minus. Then if we say this 3I minus multiply by negative 3I, 3 minus I in brackets negative 3 minus I, then we're gonna get, it's gonna be 3 times 3 is gonna be minus 9. 3 times minus 3 is gonna be minus 3I. Then 3 times this one is gonna be plus 3I. then plus I squared. What is I squared? So if we say I equals to square root of -1, then if we square both sides, you will see that our I squared is going to be equals to -1. So which means instead of writing I squared, we can just write -1. So this will cancel with this. Then we're gonna remain with -9 plus 1, which is gonna be -10. So now here we're going to have -9, -10 minus, in brackets, -10, which is going to give us plus, which is gonna be 0. So we're also gonna get 0 this side, as we have seen. Then here is going to be 0, 0. So now we will have a V. Remember, this is V1 minus, or you can use plus V2, which is equals to 0. So when we do that, we have 3 minus I, which is for side of V1. So which is equals to plus this one equals to 0. Then we can say in this equation, we will see that we can say 3 minus I, it can be equals to 2. So in other words, we can rewrite it as 3 minus I V1 equals to 2 V2. So what will happen if we substitute V1? If we substitute, if we let V1 equals to 0 or V1 equals to 1, if we let V2, let's say V2 equals to 1, then you will see that your V1 is going to be equals to 2 divided by 3 minus I. So it's gonna be 2 divided by 3 minus I. So when we have this, so in this equation, if we rewrite it, you gonna see that because of this I here, we gonna rewrite this matrix as V1 and V2 to be equal to a matrix of 2 into 3 minus I. Exactly this way. I'm still gonna explain as when we go further why are we doing it like that. So when we rewrite this matrix in this form, like is equals to that, is because of here, even if you substitute 1 here, this matrix is gonna be the same, more of exactly the same way as this one, even if it does not matter which side are you going to substitute the value of 1. So when we rewrite this, you can rewrite this matrix. You can see that here we have 2 and 3, whereby I can decide to write it as 2 over 3. This is 2 over 3, 2 of 3. Then because of negative here, I can still say plus, but when I change here, I write I, because this side there was no I, it will be 0. And here we have negative I, and we said plus here, we're gonna use -1. So now we have written this matrix in that form. So it means that in our solution, our x1 of t is going to be equal to, so when we change this matrix here, it's going to change, you're gonna write this 3 here on top, it's gonna be 3 into 2 this way. Then when you write 3 into 2, it's because of the formula for finding the I. It says cos, it changes, the matrix must be inverse. He says cos of, it can be cos of t minus I sine of t. So when we write this one, it's going to be 3 over 2 cos 3 over 2 cos t, then minus, where there is I, our value, we got that it was 0 and what? Negative 1. You can put 0 and negative 1, which is of sine t. So when we have done this one, so if you try to work it out, you will find that this matrix is going to give you, we can work, it's going to be 3 cos t and 2 cos of t. Then this is going to be plus here. It's going to be plus 0 of sine. If we take out this negative out, it's going to be plus 0 of sine t. So now after this one, you can just use the rules of matrix. If you add these two, oh, sorry, there is a mistake that I did there. Here it must be this side here. You must write it as it is here. The way we got it, we got 2 into 3. So you must write it as it is. So which means even here I'm gonna erase, it's gonna be 2, 3 into 2. So now when we add this, it's going to be 3 cos t plus 0 is gonna be 3 cos t. And then this one plus this one is gonna be 2 cos t plus sine t. So now we have managed to get the x1 of t. So we're gonna be left with the other part. So in this question here, if we check, we have managed to get this part. The x of t is in this form. So we have managed to get only one form. Then we are going to get for the xp. We are going to work with the xp now. So in order to find the xp, so the xp, you can see the formula. This is the formula for the xp. So I'm gonna erase so that I can have a space. So in order to get the xp, our thing of t is going to be equal to, we are going to use that the same matrix. So the matrix that we are going to use is this one. We were given that it have 3, we have 3, we have 2 and 3 here. We use this part firstly, then we also left with this 3 and 2. So we are going to use this 2 and 3. So we're going to alert it to be equal to 2 cos. The way we wrote it, if you see our pattern there, in the first one, it was cos and sine. Cos, we got the first one that we got there. It was 2 cos t, and we also have 3 cos t plus sine t. So we're gonna rewrite it as this is equals to 2 cos t, and then we also have 3 cos t plus sine t. Then we also going to have here, the other side will be 2 sine t, and also it will be 3 sine t, 3 sine t plus, not mine, it's gonna be minus cos t. So you might be surprised, how are we getting these other values? So I will show you now how are we getting these other values. In the first matrix, the first one that we got now, we got that it was sine, it was cos t, and 3 cos t plus sine t. So if we integrate, when you integrate, if you say integration of cos t dt, if we have 2, yeah, this is going to be equals to 2 integration of cos t dt. Then the integration of cos t, this one is going to be 2. The integration of cos t is just going to be sine t. Sine t. So we're going to have 2 sine t. But when you integrate sine, when you say integration of sine t dt, the integration of sine t, it becomes negative cos t. So if we go back to this equation, you will see that here you have 2 cos t. So which means because when you integrate cos t, it's going to give you sine t. So we're going to have 2 sine t. But in this one for 3 cos t, when we integrate cos t, we know that it's going to be 3 sine t. But when it's sine, when we integrate sine, it's going to give us negative. So that's why here we write negative cos t. So that's how we found that these values that I just show you, how you get them. So now, when we already have this one, we already have this Q of t, so this matrix. So now we will have to find the inverse of that matrix. So to find the inverse, we will have to first determine the determinant of this matrix, this one we just got now. To get the delta, so determinant delta of qt, q of t, it's not q delta. Yeah, I just forgot the name, but it's fine. So to get the delta, we know that we get the absolute value of everything there. When we get the absolute value, going to be absolute value to cos t yeah, and is it 2 cos t? Let me check. Yeah, it's 2 cos t and 2, which means this side is going to be 2 sine t. Then it was 3 cos t plus sine t. So even this side is going to be 3 sine t minus cos t. So now when we get this absolute value, then we're going to find that in this one, if you multiply, you will do the cross. It's going to be 3, which is going to be 3 times 2 is going to be 6. This 3 times 2 is going to be 6 cos t sine t minus, this is going to be 2 cos squared t. Then you say minus, you do the same. This times this is going to give you 6 again, cos t sine t. And then this one is going to be plus cos, not cos, is sine squared plus sine squared t. So now we will see that if this one here, it will cancel with this. Then we're gonna remain with sine. This is going to be 2. Here there is 2 because there is 2 there. When I remain with 2 sine squared t minus cos 2 cos squared t. So if we take out negative 2 here, then we're gonna have negative 2. Then we're gonna, if we take out negative 2, it's gonna say, or if we take out, yeah, let's say negative 2, we're gonna have cos squared t. So let's just verify something. Remember, this is minus negative. So here it's going to say negative, and here also it must be negative, because when you say this one times this one, it's going to say negative in brackets. Everything, it must be negative. So it means also here it must be negative. Then we're going to have negative 2 out. It's going to be, say, cos squared t plus sine squared t. So cos squared t plus sine squared t, according to the rules of trigonometry, we know that equals to 1. Then answer here is going to be 2. So now when we have delta, which is equal to 2, so in order for me to find the q only of this one for delta of inverse, I will have to multiply it by the 1 over delta of q of t. Then we are going to swap the 2. We swap this one. You're gonna swap, this one will come the other side, this one will come the other side. These 2 will swap. Then you multiply by negative. You will see the other 2, you leave them this remain same. Then you multiply it by negative. So when you rewrite it, it's going to be in this way. It's going to be 3 sine t minus cos t. Then after that, the cos 2t is going to be this side, the way I showed you, cos t. Then the other 2, they will remain the same, gonna be minus. Here, that one was 2 sine x. So we multiply it by negative, then it's gonna be minus 2 sine x. Then this one, the other one, it remains the same, but you also multiply it with negative. So it's gonna be, you can see that is positive. When you multiply everything by negative, you want to say minus 3 cos t minus sine t. It'll be minus 3 cos t minus sine t. So now we have solved this part. Now we can say this is the same as negative. Our delta of this is negative 2. We can just write it as negative 2 like that. After of what we just recopy, or instead of me not to waste time, let me just erase here. Then instead, you know that is 1 over delta of a of this symbol. Then you're gonna just write, and our delta was negative 2, then we can just write as negative 2 like that. So now I can decide if I want to make some changes. I can take out a negative outside here. We have negative here, and we also have negative. So if I multiply everything by negative, or negative 1, the whole equation by negative, then we're gonna have the answer, which is 1 over 2. Then everything that, if I multiply this equation by negative 3 sine t minus cos t, it will end up becoming cos of t minus 3 sine t. And if you multiply this one by negative, it's going to be 2 cos t sine t. Then we multiply this by negative, it's going to be 3 cos t plus sin t, then negative 2 cos t. So we just wrote this is the inverse, remember? So now we have written that, we have found that one for the inverse. So the function that we have there, we were given that the q, this of t, is not the q, let's say xp. Our xp is equals to the t0. Our t0 was pi over 2. As you can see there, we are given that t of 0 is pi over 2. This, we are copying this formula, but we are substituting everything that need to be substituted there. We have t0, which is pi over 2 up to t, and then also the q of inverse, we already found the inverse, and f of s ds, this means derivative, antiderivative. So now when we rewrite it back, it's going to be up to t. Then we're going to substitute this matrix that we just got now here. When we substitute this matrix, you will see that here, if I substitute, it's going to be 1 over 2
Hello?
Hello? Can you hear me?
Oh, I think you cut off just now.
Or is it fine now?
Yes,
All
it's
right.
fine.
All right. So what I'm doing, I'm using this equation, this formula. I'm just substituting what we have done. We have already find this one. Then when we substitute back to our equation, we just rewrite this matrix the way it is inside our integral. Then it's going to be plus sine t, and then it's 2 sine t minus 2 cos t. So everything that we are writing is just that due to space. Yeah, I think I'm going to have a space. So after this one here, everything that we just wrote there is going to be into our f of x, f of s is going to be this one. We have x, when our x, f of s is this one, this value here, this matrix 3 and 2. So we're going to multiply this equation by 3 over 2. 3 and 2 of ds of ds. So now because here we are working with ds of ds according to our formula here, everything is f of q of s. So now we must not, here where there is t, we must write as, we can just change that. So if in here, instead of using t, we're going to use s, then it's going to be s. So we can take out the common factor, out this the constant, which is number 2, 1 over 2. So when we take it out, it will be equal to I'm just copying this matrix. So now, beside that, before I even copy, you can see that if we say this times this plus this times this, it's going to multiply everything we have with 2. 3 times this one is gonna give us gonna be saying 3x 3 cos s, and then also if you multiply, this is 2 here, this is 3 ne? Let me rewrite it. So as it is there in this equation is 2 and 3. So if we say this times this one is gonna be 2 cos x, and everything is gonna be in terms of 2, 6. And I say 2 and 6 again. Then you, okay, I'm not sure. Do I have to do this part, or are you fine with it? Or should I just do it quickly?
Can you do it quickly?
Okay, it's fine. So if we have this matrix there, when you do it, you're going to say this multiply by this one. It's going to multiply by 2. It's going to multiply the whole equation here by 2. Then you will see that we have, let me just erase here so that you can see what I'm talking about. You will see that we have 2. When I say 2 cos s minus 6 sine s. Then you multiply this one by this one, it's gonna be 6 sine s. Then we do the same. This one multiplied by 2 again is gonna be, now it's gonna be 6 cos of x plus 6 3 2 sine. This one multiplied by 2, 2 sine s. Then this one times 3 is gonna be minus 6 sine cos of s. Then it's gonna be d of s. So now we have done that part. So what will happen when we integrate now? If we take out, when we integrate this one, we are going to find that this part here is going to be equal to, so if we check here, there is in this matrix, you will see that we have some things in common, whereby when we have some things in common, there are things that are going to be canceling here. This one here, it will cancel with this one, and this one will cancel with this one. Then you will remain with, I'm just gonna write it perfectly so that you don't, so that you must not be lost. Then we're gonna have q over 2 integral of pi over 2 to t. Then we are going to be remaining with 2 cos s and we're also gonna remain with 2 sine of s ds. So you can see in this one that we have what? We have 2 in common. If I take out 2, then I can rewrite this as q I can take out 2 outside of the integral. Then I will have pi over 2 to t cos s sine s. Then yeah, I just don't have, I think I'm okay, I think I do. Okay, I no longer have a space, but we're gonna have d of s. So these 2 we just take out, it will cancel with this one. Then what we're gonna remain with, we're gonna remain with q, yeah, of t not t, is s. Sorry, I'm just used to t. Then integral pi over 2 of t of cos s sine s ds. So we have reached this point. So when we have reached this point, we are going to integrate now. I'm gonna cancel. Can I cancel here?
Yes.
All right. I'm gonna integrate now. In this one, I'm just gonna rewrite it. We have q not q of s is our answer was equal to, remember here we are finding x of p. This is x. Here we are still working on x of p of t. We found that is q of s integral of pi over 2 to t of cos x and sine s of ds. So now when we integrate this one here, you will see that we are going to get, we're going to have q of t, q of s. Then the integration of this, the cos, we know that is going to be sine s. And the integration, when you integrate sine, is negative cos. Negative cos s. Then this is between pi. This is a definite integral, by the way. Is pi over 2. Pi over 2 over 2 to t. So now what will happen? We are going to substitute the t and pi over 2. So when we substitute t and pi over 2, you will see that if we do that, we are going to have equals to we are going to have, if you substitute t in cos, in sine here, we're going to have sine t. And if we say, when we work this kind of integral, after when we have the lower and the upper, we say minus. It's going to be minus. Then we substitute sine of pi over 2. Sine of pi over 2, according to the graph goes this way. So sine of pi over 2, sine pi over 2 is 90. Then it's going to be 1. Sine pi over 2 is 1. Then we're going to be right 1 here. Then we do the same with cos. It's going to have negative cos of t. But in cos, when the graph of cos starts at 1, it goes this way. Cos 90 degrees is 0. So which means it's just going to be plus 0. We can leave it like that. Then we have this, the way it is, the way we have written it. So now we are done. We are almost done with our work. So now we are going to get the general formula. General formula. So in order to get the general, not formula, the general solution, the general solution. So in order for us to get the general solutions, we know that our x of pi over 2 was equal to 4 over 7. 4 over 7, yes, is 7 over 4. When we know this one equals to 7 over 4, then we can, based on this matrix here we have written, we can mention that this is the same as equal to 0, 0. I'm going to explain how you get that, plus 0 and 2, 1 and 3. So if we go to our question here, oh, sorry, I'm opening wrong up. Oh. So if we go to our question, you will see that in this question here, we have 3 and a 2. So when we have 3 and 2, what we got there, we got that here when we substitute x of pi over 2, we get 4/7. So when you get 4/7, we also worked on the integral part in this equation here, where we substituted pi into t, where we substituted pi into what? Into t, pi over 2 into t for this one here. So the answer that we end up getting, we get sine t minus 1, and then we also got negative t cos t. So now when we have this, so if we let this equals to, if we solve this matrix here, you will see that we are going to get the other one is going to give you this one here. If we put sine 0, if we say we substitute as ours, this one is not, yeah, if we substitute this one as, if we make our t to be equals to, let me go back again. Remember our t, here our t was given as what? As pi over 2, t0 as pi over 2, and we already used it. So if we substitute back here in this equation, you say sine t, you will see that you are going to get what? Sine t is sine pi over 2 is going to give you 1. So 1 minus 1 is going to give you 0. Then you're going to write this 0 that I wrote there. I'm showing you first with this one. You're going to write this 0. Then if you substitute negative sine t is going to give you negative 1. It's going to be positive 1 multiplied by this negative there, whereby this, when you say cos t, you get what you get. You're going to get 1. So this is the 1 that you write there. Then the 3 and the 2, they are the ones that they are given in this equation, 3 and 2. So for this one, when we say there is 0, when we say this side here, we are adding 0 plus 0, is because of the first solution that we have. It must start the initial solution that we have there. When this one, we start at 0. Remember, when we get a solution, normally when we get v1 and v2 in the matrix, we make it to be 0 and 0 this way. Okay. So I mean this one, you know that I'm going to say this equals to 0. So if we can take it the other side, if I write it as a matrix like this, I say equals to 0, then I can take this the other side. So that's why you have to write this 0 like that. So when we write this one like that, it's because of here we are saying in this equation 7/4 is equals to everything there from here to there. So when is the same as that, we know that we're gonna be needing a value of, it can be value of v1 and v2, just that we can use different values because we already use v1 and v2. We can use maybe any value. You can decide to use k1 and k2. So when you use it this way, when you write it this way, now you can solve this matrix. You will see that you are going to get this is equals to, we are just eliminating everything there. This plus this is 2k1. 1 times k2 is going to be k2. No, not k, not is this one. Actually, I did it wrong here so that I can explain it properly. Times k1 is going to be 0. 2 times k2, then you're going to have 2k2. Then 1 times k1 is going to be k1 plus 3 times k2 is going to be 3k2. So we have that. When you have that, now remember this is equals to 7 over 4. So when this is equal to 7 over 4, so it can imply to us that okay, it's fine. Is equals to 7 over 4. So when it's 7 over 4, we can see that our k, we can make these values to be exactly the same as this one. We can rewrite it down we can rewrite it down. So when we rewrite this down, it can be okay. So when we rewrite it, it can be, or we can write it. I want to try to get, okay, yeah. So if you check here where we have 2k2, this is 2k2, not k1. So which means in this, if we rewrite it in terms of not k, you will see that this is the same as 0, 2, is still the same as 1 and 3, like this way, which this we can say is the same as equals to 7 over 4. Yeah, this is going to be a nice way to exchange it. So if we exchange these values, you will see that we can write it as 1 and 3, whereby it's going to be 4, and 2 is going to be 7. So now we will have 2k2 equals to 7. So when we have 2k2 equals to 7, if we divide by 2, our k2 is going to be equals to 7 over 2. When our k2 is 7 over 2, when our k2 is 7 over 2, I think there is some, let me check something. Oh, yes. Yeah, there is some error that I made here. So now, since this one here, we must not use this 7 over 2, 7 over 4 now. What we are going to do, we are going to say we have equation for 2k2 into k1 plus k3, 3k2, given we can make it to be 0, 0 there. Then when we make it to be 0, 0, you can see that we can rewrite this equation as k1 plus k2 and k2 to k2 to be 0, 0 there. So when it's in this form, we can see that here in this one here, we are going to get 0. So we're gonna use only the one on top. The one on the top here is k1 plus 2k2 equals to 0. Then this one is going to say k1 equals to 2k2. So the answers here, the values, they can be inverse. So if we put k1 as 2, you will see if we let k1, k2 equals to 1, then you will see that our k1 is going to be equals to 2. So when you get these two values, one of your k, it can either be k2 or k1. It does not matter which one is going to be. So now when we have found these values that we have 1 and 2, then we can write our formula, the general formula of x of t, as equals to our x of t is going to be xp of t plus x1 plus xp of t. X of t is going to be xp of t plus q of t. Then we multiply it with this value, which is 1 and 2. 1 and 2. So when you have written it in this form, we have just solved that equation. So this is how you solve it. So our x of p, remember our x of p was the integral, whereby the integral we got that it was, you can substitute, is fine, but there is no need to take it further, whereby you can write it in this form. So you can still, but as long as you end there, then that's how you do it. So let's just do a recap. So in this one here, you will have in this, I think you do have this paper. You will see that the first step is question 3. You gonna do this one. You're gonna write to get the eigenvectors. We did that. You understand now why is it written like that. I have explained to you. Then you come to this one. I have explained also. And then you also gonna explain there. Then you go, you will see how to get an inverse now. Why you don't have negative here. I've explained everything, what is happening. Then we go to the integral. Each and every part of this integral, I've explained why, how even these two left there when you have this until this way and until you get there. Then we have this one. I've explained to you also the values, how you get them, and this function up to there. So do you have any question?
No question.
All right. So this is how, so this one, we're still gonna do more of these exercises. So if you don't have any question, I'm not sure you do you wanted us to still have another class?
Yes, we still need to do one more class.
All right, we can do it after, let's say, an hour, because I want to attend some other guys who start at 7.
Okay, so what time?
After 1 hour.
Okay.
All right. Then I will let you know.